We are on the page 36, sections 6.2 and 6.5. Okay, so we said 3 things we are learning in this class, right? First thing was what? Solving linear equations and inequalities, right? That was for your exam 1. And second thing was what? Graphing linear equations and inequalities, right? That was on your exam 2. So we are going to learn the third thing in this class. Okay, it's called polynomials. We see what it is. Okay, so before we talk about polynomials, we need to talk about few things. Okay, review few things. One is exponents. All right, we learned this before. Let's just review it. So if we write it this way, and 2 to the 5th, right? We did in on section 1.4 earlier. So the bottom one we'll call it what? A base, right? The top one we call it what? Exponent or a power, right? Then what does it mean? It means shorthand writing for the 2 times itself. How many times? 5 times. So it means what? 32, right? So the definition of the exponent is what? The exponent means the shorthand writing for repeated factors, right? Then let's see the values. So we have -3 squared. So what's your base? The whole thing inside the parentheses, right? -3. So it means -3 times twice, that would be what? 9. And if we write -3 to the second power, what's the difference between these two? One is what? With parentheses means what? Everything is the base, right? But for this one, it's different because the power applies to the thing right before it, okay? So for this power 2, the base is what? Only 3. Then you attach the sign after it, okay? So it means what? You have negative, then you do what? 3 times 3 twice. So that would be -9, okay? You need to differentiate them, and that's usually you will make mistakes on those, okay? Then next one, it can also apply to the fraction. So this one, what would you do? You multiply 1/5 by itself how many times? 3 times, right? So the answer, usually we spell it out, the numbers. If we have 5 times 6 to the second power, so what does this second power apply to? Only 6. So that would be what? 36 first. Then you times 5. That would be 180. Right? So we are reviewing what? Exponent. Okay, for numbers. Then we are going to do it on the variables as well. If we have 27, we want to write it in the exponential forms. Then what do? You do your trees, right? You break down. So that would be the bottom one, or the prime numbers. So you will write a what? 3 to the third power, right? If you have negative 36, what would you do? You keep the negative by itself attached to the numbers behind it, right? So you break down this 6, 6, you break down 2 and 3, 2 and 3, right? Those, we call them branches. And in the middle, we call them tree trunks, right? We don't need to worry about them. We want to what? The bottom one, or the prime numbers, we call them tree leaves. Okay, so you have 2, the 2, and 2 of the 3. So you will write in prime forms that way to break down. Okay, to write it in power forms. All right, then let's see how we are going to deal with variables. Okay, if we say 3x squared is what kind of value? If x is 4, what do you need to do? You plug in x with 4, right? It's better you put the parentheses around your variable, so to take care of the negative signs. You see, they make difference, right? So what do we have? That's 3 times 16, that would be 48, right? If we have this one, we say, what's the x4 divided by negative 8? If x is negative 2, what would you do? You plug in, right? Do you write it this way? Not really, because the whole base for the fourth power is the x. So you need to put the whole thing as a base. So you need to put the whole thing as a base. Otherwise, your sign will not be correct, right? Then divided by negative 8. So that will be negative 2 times 4 times itself. It's a positive, right? Even number of negative would be positive. So divided by negative 8, that would be negative 2. If you don't put a parenthesis there, you end up what? A negative number, which will not be correct, because it should be what? Positive number. If you multiply a negative number 4 times, even times would be positive, right? If you multiply a negative numbers and odd times, means multiply them 1 or 3 times, 5 times, right? 5 times, then that would be negative number. But even times, you should get what? Positive number. So we are talking about what? Exponents, right? Then we want to see how exponents behave either with numbers or with the XYZ. Okay, so let's take a look. If we have 4 squared times 4 cubed, what do you think? How many 4s you have? Here 2 of them, here 3 of them. It's a shorthand writing of the multiplication, right? So you just count them to, so how many of them? Fifth. How did you get 5? So you add them together, right? By adding them together. If you have x squared times x third, then how many x's you have? 5. X is your base. So you what? Add the power, right? So if you have x tenth times x 60th, how many you have? X 70. Right? So we are talking about if you have AM times AN, how many A's you have? You will add your power, right? So we call this one what? Product property, because we multiply the same base, you will what? Add your power. Is that right? Okay, and let's see more examples. Then let's take a look. If you have y fifth times y, how many? 3, right? So for the shorthand writing, how many y's you have? This one is what? Invisible 1. So how many you have? Y to the 9th power, right? If you look the second one, 5 fourths times x squared times 5 second, 5 to the 2nd power, right? Usually number will spell it out, but for now we are practicing the powers. So we just leave it as the power form. Okay, how many 5s you have? 4 and 2, total 6. How many x's you have? 2 and 7, that would be 9. Right? In between numbers and the variables, if nothing in between, it means what? Multiplication. Okay? Usually we don't have to write it. And if we have this one, so you will take care of sign within themselves. Then you take care of the variables with variables. So what you want to do is you only wanted to write what? One variable, one power. You don't want to spread it out too many same variables, many places, right? Okay, so you take care of the sign first. Negative times positive is what? Negative. How about number? You have nothing here. That means invisible 1. So 1 times 4 is 4. Then how many x's? 9 and 2. Total would be 11. How many y's? 1 and 11. That would be 12. Right? Next one. So what do we have? It means what? 5x times 5x. That would be 5 times 5, 25. Simple one, we just spell it out. X, how many? 2 of them. Right? So what do? We were just practicing what? The product property. Okay? When you have same base, then you just combine your power by adding them. Then that would be the simplest form to show, right? So you want to write it in the simplest way. Let's look at the next one. So we're multiplying, okay? Then we do the divide. So we practice exponents first, then we do multiplication and division. Okay, so let's see. If I have 4/5 power divided by 4 to the second power, what do you think? This one means what? How many 4s you have? 5 of them. This one means what? 2 of them, right? So you cancel out 2. How many you have left? 3 of them, right? So if you want to write it directly, 5 and 2, how did you get a 3? You minus them. Is that right? Okay. If you have x 6 power divided by x squared, what do you think? How many x's you have left? 4 of them. Is that right? If you have same base, then different power, you need to consolidate them, make it simpler, right? So next thing we are doing if same base, an divided by an, right? So how many a's left? Will be a m minus n, right? So you will subtract your powers. So when we divide things, we call them what? Quotient, right? So if it's the same base, n, you will put the power together by subtracting them, because you take away the how many on the bottom from the top. So you take away, you will minus them, right? Equal 3. So let's see more examples. If we have 5/9 over 5/6, so how many left? 5/3 by subtracting them, right? So you can write that way, or you can write 125. How about -2 to the 14, -2 to the 10th power? Do we have same base? Yes, which is -2. So same base, you subtract your power. Do you write it this way? Be careful. What's your base? It's the whole thing. You need to take care of that. So -2 times 4 times 16, positive or negative? Positive, because it's what? Even times. Okay, next one, x 10th divided by x squared. So your answer should be x to the 8th power, right? If you have this one, okay, 16 a to the 16th power, c to the 11th power over 4a to the 4th power and c. What do you think? You take care of the numbers with numbers, same variable with same variable. Okay, 16 divided by 4, 4. Then a, same base, how many you have left? 16 minus 4 is 12. How many c's left? 11 minus invisible 1, so you have 10 of them left, right? So for our answers, we always write a what? Each individual variable once with its own power. Okay? Then you combine your numbers all together. Let's look at the next one. If I have this situation, 4 squared to the 3rd power, which is different from those, right? This one is individual, it's 2 of them and 3 of them. This one you will have what? 5 of them. But this one is different. This one is what? Base is 4 squared itself. Then you have to multiply 4 squared 3 times. How many 4s you have? 2 and 2 and 2. Total is what? 6. How can you get a 6 directly from previous numbers, 2 and 3? You need to multiply them. Is that right? So power on power, you need to multiply your powers. Okay? So if you have x fourths to the 2nd power, how many x's you have? You have 8 of them, because 4th times another x fourth, total is 8. Okay? So you need to be careful which one you are using. Okay? If you have a base to the n power times to the n power, what's the result? A to the mn. So you need to do what? You need to multiply your power, not adding. You need to multiply them. Okay? So this property we call it power property. Power on power. You need to multiply your power. Okay? Those are one variable. How you would handle your powers. Okay? We'll have more practice on the right hand side. So if you have 9/4 to the 10th power, how many 9s you have? You multiply them, right? And if we have this one, x squared to the 3rd and x fourth to the 5th, what do you think? Too many powers everywhere. You need to consolidate them. So you will do one at a time. How many x's you have? Power on power, power property, you multiply them. Then power on power will be 20, right? Now, do you have x 120? No, you don't multiply them anymore because it's now power on power. It's separate power. Then you need to what? Add them. So that will be 26. You need to differentiate them. Okay? You are using power property or use product property. This is all one base, one same kind of base. Okay? If we have different kind of bases together, so we have 2 bases inside, then let's see what will happen. Okay? It means what? xy times itself 3 times. Then how many x you have? 3 of them. How many y you have? 3 of them. When you have more than one base inside the power, it means what? Each one has to be applied with the power. Is that right? So we are saying if you have 2 different bases inside the power, it means what? How many A's you have? N of them. How many B's you have? N of them. That means what? When you have something multiplied together already inside as a base, right? So when a product, okay, inside the parentheses as a base, then your powers need to distribute to each one of them. And this one we'll call it what? When you apply a power of a product. When you apply a power to a product, you need to do what? You need to distribute your powers to everyone. Right? Okay. And let's see some examples. So if we have -5 x cubed y what? To the second power. Okay? You have -5. How many bases inside the parentheses? 3 things. One is the number, one is the x, one is the y. So when we want to show the answer, we don't want to have a parenthesis. We want to write individual things with its own power, okay? And number with itself. So -5 times twice is what? 25. Then x3 to the second power. So you have 3 to the second power. That would be power on power. You multiply. You need to distribute your power to every base inside the parentheses. So y is how many power? Second power. Right? Let's look next one. 1/3 and n third power to the second and fourth to the n. Right? So, too many n's everywhere, too many n's everywhere, too many powers. Then we want to write it clean. Okay? So you distribute them. So 1/3 times twice will be what? 1/9. Right? Don't give me 1/6. You need to multiply them. So m how many powers? Square, right? N how many powers? 3 and 2 again. That would be what? Multiplying. 6. Power on power. Then you times what? m4 to the n. Still too many m's everywhere. So you consolidate them. M how many? 2 and 4 total? 6. 6 of them, and invisible one here. How many n's? That would be 7. Right? Then we take a look at this one. X plus y squared. Okay, we know xy to the square multiply if base are multiplied together, a product, then you can distribute because you are multiplying them out, then you squeeze them together and write in shorthand writing. This one, okay, it's not x squared plus y squared. We didn't say you can distribute that. You cannot do that. Okay, this one means what? X times y times x times y. X plus y times x plus y, right? Which is not this one. Okay, we will do it later. We will show you how to multiply them. Right now, we just do what? Individual variables multiplying. Okay, then with the exponents, then you need to know how to handle them. We are not talking about adding and subtracting yet. Okay, so right now we are just doing what? Everything is multiplying together or dividing, right? Okay, so next one we have, if you have this situation, it's the quotient, right? Same thing, what would you have? You multiply them 3 times, so you have x cubed on the top, y cubed on the top, right? So you need to what? Distribute your 3 into each of them inside the parentheses to your base. Okay, so when we have this situation, a over b to the nth power, we should have what? A to the nth, b to the nth, right? Of course, the denominator cannot be 0. So when we have a quotient inside the parentheses as a base, then you need to distribute your power to everything inside, right? So we say this one is what? A power of what? A quotient. You need to apply everything into the quotient before it. Okay? So, if we have example like this, what do you think? How many x's? Power on power, you multiply that, right? Then y would be 4 of them, right? And next one, if we have 5x to the 6th power over negative 4y cubed to the 2nd power, what do you think? How many things inside the parentheses? Different things. 5 and x6, negative 4 and y cubed, right? Then your 2nd power needs to apply to every one of them. 5 squared, 25, x6 to the 2nd power, power on power, power property. So that's 12. And negative 4 twice, 16, y third to the square, y 6. Right? And next one, we are talking about something to the 0 power. Okay? We learned this before. We say anything to the 0 power is what? Not a 0. We say 5 to the 0 power in your, arithmetics class. We say it's 1, 6 to the power. Anything to the 0 power is 1. Okay? So we are talking about what? 0 exponent. Okay? Let's observe how it works. Okay? So if my x squared divided by x squared, what do you think? Right? If we do quotient property, what do? We will subtract our power, right? Then we end up to what? X to the 0 power. Okay, we don't use base as 0. Another way to do it is what? If we can look at this way. X squared, right? X squared means what? X times x by itself twice. Same thing, it's all multiplication and division, right? So you can cancel out. So what do you think the answer would be? Would be 1, right? And the answers look different. One is what? X to the 0 power, one is 1. But for math, same question, can we have 2 different answers? No, we don't do that. Right? So it means what? These 2 things should be the same. So that's what it's saying. If the base is not 0, anything to the 0 power is what? 1. Okay? So we call this one what? 0 exponents. 0 exponent. So anything to the 0 power is what? 1. Okay? If you look at some numbers, so in general, x to the 0 power is 1. X cannot be 0. We don't use basis 0. Okay? So we say 3 to the 0 power is what? 1. Negative 5 to the 0 power should be 1. Right? Anything if it's not 0. So how about 3 to the 100 to the 0 power? It should be 1. Right? And a to the 0 power is 1. Of course, base is not 0. How about this? AB to the 0 power should be, anything to the 0 power should be 1. But the base cannot be 0. Right? Okay, so you need to remember all those rules and properties. Okay, when we get more complicated situation, make sure you do it correctly. All right, if we have a more complicated situation like this, m to the 3rd power to the 8th power divided by 5, m to the 5th power, and whole thing we take a square again. Okay, we want to simplify it. Too many m's, too many powers. Okay, what should we do? Many ways. Okay, so probably we can do the inside first to simplify it, right? So take a look, how many m's on the numerator? Product property, right? So add the power, then m to the 5th power to the square, right? Then let's simplify inside again, m to the 11 over 5th. That will be quotient property, so that will be m6 to the 2nd power. Now power on power, we will use power property, you multiply them. So that would be your answer, right? Not too bad. But look at this one. That would be 3 to the 3rd power and negative 3x4 to the 2nd power over 2 to the x5th to the 3rd. Many things. Too many of them, same thing over and over. So what do we want to do? Right? We write it individually first without parentheses would be easier. Okay? Then you consolidate it. So this one, how many things inside the 3rd power? 2 of them. So you write it individually. 2 to the 3rd power, x3 to the 3 power. Can we do that? And this one, 2 things, each one has 2nd power. So you write it negative 3 to the 2nd power, x4 to the 2nd power, right? Then this one will be 2 to the 3rd power, x5th to the 3rd power. Is that right? Okay, and let's see. So that would be 2 to the 3rd power, 8, and x3 to the 3rd power, power on power, 9 of them. This one is what? Negative 3 twice is 9, x4 and the square, 8 of them, right? Then this one, 2 to the 3rd power is 8, x5, x5th to the 3rd, 15, right? Then we can cancel this and see what will happen. So on the top, numerator would be what? 9 and how many x's? 9 and 8, 17, right? Over x15, right? Still too many x's. Then with quotient property, you subtract your power. So that would be 9x to the what? Square. Right? You need to practice before it sinks in. All right, otherwise you will mess up with power property and product property. Okay? So we are talking about what? The base with the power, right? How do they work together? Or with all the multiplication and division, how do we consolidate them to write as simple as possible? Okay, so that would be the exponents we are talking about for the sections 6.2 and 6.5.